And our last page brings us to our last section, section 6.6, solving radical equations and equations with fractional exponents. So if I want to solve and check for extraneous solutions, my goal is to isolate x. So that's going to involve subtracting 9. So 2x to the 3/4 equals, that's going to give me 54. And then dividing both sides by 2. So x to the 3/4 equals 27. Now, in order to get rid of that fractional exponent, if we've got x to the 3/4, I want to take it to the power of 4/3, because remember that when you take a power to another power, you multiply exponents. Well, multiplying 3/4 times 4/3, you just get x to the first, which is what we want. So we take both sides to the 4/3 power. We get x by itself, and then I'm going to rewrite 27 to the 4/3 in cubic root form. So cubed root of 27 all to the 4th power. Cubed root of 27 is 3. 3 to the 4th is 81. X equals 81. I plug my answer back in to make sure that I can actually take 81 to the 3/4 power. And I do. I multiply by 2 and I add 9 and I get 63. So I do not have any extraneous solutions. Problem 10, A, B, C, and D, we have radical equations now. Still the same process, really. It just involves taking both sides to a power to get rid of the radical instead of the fractional exponent. So I have the 4th root on the right-hand side. Well, I better take both sides to the 4th power, so it'll undo each other. So I have 81 equals x plus 8. Subtracting 8, I get 73. I plug it back in to make sure I don't have any extraneous solutions. Does 3 in fact equal the 4th root of 73 plus 8? Well, 73 plus 8 is 81, so yep, 4th root of 81 is 3. No extraneous solutions. In example B, I have 2 cubed roots. So I'm going to take both sides to the 3rd power, and sure enough, it cancels on both sides, which is great. X plus 4 equals 3x then. I'm going to subtract x from both sides. X equals 2x. Dividing by 2, I find that x is 2. I'm going to plug it back into my original equation. Is the cubed root of 2 plus 4, that would give me 6, in fact equal to the cubed root of 3 times 2, which is 6? Yeah, sure is. Honestly, if we had negatives inside our radicals, which we obviously don't, but if we had, that wouldn't bother us either, because you can take the cubed root of a negative number. In example C then, when I square both sides to get rid of that square root, note that on the right, we're going to be squaring a binomial, so we are really going to be foiling. On the left, it cancels. I have 2 minus x. On the right, x squared, outsides minus 2x and insides minus 2x. Last, negative 2 times negative 2, positive 4. I'm going to combine my right-hand side, x squared minus 4x plus 4. I'm going to add x to both sides, and I'm going to subtract 2 simultaneously to find 0 on one side of my equation. I have to get 0 on one side in order to ever be able to solve a quadratic equation. This guy is factorable. I need 2 numbers that multiply to 2 and add to 3. Well, it's 2 and 1. My signs are the same. They are both negative, minus 2, minus 1. Setting both sets of parentheses equal to 0, we find that our answers are positive 2 and positive 1. I have to plug them back into my original equation to see if I have any extraneous solutions. So checking x equals positive 2. On the left, I have 2 minus 2 under my radical. I have regular 0. And then on the right, I also have 0. Cool. We're okay there. For x equals positive 1, plugging that guy in, 2 minus 1, I have radical 1. On the right, I have 1 minus 2, which is negative 1. Oops. Is the square root of 1 ever going to be negative? No. So x equals negative 1 is extraneous. Last problem, example D, I need to start by squaring both sides. Now, normally we like to isolate radicals. I won't be able to, though, so I'm just not going to bother. So I square both sides, and again, when I square the right-hand side, that's going to involve multiplying by itself. So I have 3x plus 1 on the left. Not bad. On the right, multiplying my firsts, I get 16. outsides 4 and negative 5, or excuse me, radical 5 minus x. Cool. 4 5 times the square root of 5 minus x. And then great news, that's the same thing as my inside. So minus 4 square root 5 minus x. My two last terms, well, the square root of 5 minus x times the square root of 5 minus x is just 5 minus x. And then I'm going to combine like radicals over here on the right. So I have 3x plus 1 equals 16 minus 8 radical 5 minus x plus 5 minus x. Well, let's go ahead and absorb that plus 5 into that 16. 16 plus 5, I've got that 21. And this minus x still outside. Now I still have a radical, but I'm going to go ahead and isolate that side so that I can, or isolate that radical so I can square both sides. So that's going to involve adding x to both sides and subtracting 21. When I add x to both sides, I have 4 x's. Positive 1 minus 20, negative 20, equals negative 8 times the square root of 5 minus x. Now, I can't get rid of that negative 8. I mean, I can, but I'd be dealing with fractions. So what I'm going to go ahead and do is divide everything by a negative 4 or a positive 4. Honestly, it does not matter, and I think on my answer key I did positive 4. Truly doesn't matter. But dividing everything by 4 is at least going to give me smaller numbers to work with, and let's just keep it positive 4, because why make it different? So then I've got x minus 5 equaling negative 2 times the square root of 5 minus x, and that's just a way nicer thing to look at. I square both sides. Now, remember when you square on the right, you have to square the negative 2 and the radical, so we get a positive 4 and a plain old 5 minus x. On the left, we would FOIL that or double distribute. We get x squared minus 10x plus 25. We're going to go ahead and solve from here now. So x squared minus 10x plus 25 equals, we distribute 20 minus 4x. I'm going to go ahead and get 0 on one side because that's how I solve quadratics. So I subtract 20 and I add 4x. And I get 0. Let's see, minus 20 gives me a plus 5. Plus 4x gives me a negative 6x. So this guy factors into x and 5 and x and 1. My signs are the same. They are both minus. X minus 5, x minus 1. Setting them both separately equal to 0. I get x equals positive 5 and x equals positive 1. And I check to make sure that neither are extraneous. So I've got, when I plug in positive 5, I've got the square root of 15 plus 1. Hey, that's the square root of 16. Is that in fact equal to 4 minus, well, 5 minus 5, even under a radical, still 0. So 4 minus 0. Cool, x equals 5 is a solution. And then checking x equals 1, I've got the square root of 3 times 1 is 3, plus 1 is 4. Is that equal to, well, first of all, it is equal to 2, so the right-hand side better be 2. 4 minus the square root of 4. Well, we just said the square root of 4 was 2. 4 minus 2 is 2. Oh, thank goodness they are both real solutions. Neither are extraneous.